we see then that Km and Kcat are both really important values in terms of understanding an enzyme, both its efficiency and how much it desires its substrate. But how do we go about finding those? How do we determine what the Kcat is or the Km is? And how do we do that based on such a convoluted hyperbolic graph as we see that normally describes this function? So I guess that is one answer, is by looking at that normal plot. And just to remind ourselves by again and again about this plot, because it's so important, where we have initial velocity as a function of substrate concentration with our hyperbolic curve. Well, you could say, hey, you can determine Vmax because it is the value that the function approaches. That's true. It is. That's hard though. It's an asymptote, right? So we know it's approaching that forever, and so actually getting a value for that Vmax can be difficult at best. Now, certainly with the right computer and the right computer program, the equation describing this hyperbola can certainly be used to do that, to explain not only and solve not only for Vmax, but also, of course, for that substrate concentration Km that happens at 1/2 Vmax. But this is a tricky way of going about things, and so in order to simplify the determinations of Km and Vmax, and certainly once you know Vmax, right, you can solve for Kcat, because we remember the equation that allows us to do that, where Vmax is equal to Kcat times total enzyme concentration. Sorry, that is an E in there, and that's a T for enzyme total. So we know that those two can be calculated based upon one another as long as you have a real accurate determination of the absolute amount of enzyme that was added. So those two could be calculated from one another. So let's talk about some easier ways though of getting Vmax and Km, and then therefore making it easier to get Kcat. And the first method that's a bit easier is termed the double reciprocal plot, or also known as the Lineweaver-Burke plot. Well, let's go ahead and look at that. What happens with this is that basically the double reciprocal is taken, and by that we mean that the value on the y-axis is the reciprocal of initial velocity, and then the value on the x-axis is the reciprocal of substrate concentration. This allows then for the function that is described to be a much simpler function. In fact, it is a line. And the best thing about it is that the intercept, the y-intercept, is equal to 1 over Vmax. And the x-intercept is equal to negative 1 over Km. That sounds easier already, doesn't it? Because we know that this line is just simply going to have the standard equation of y equals mx plus b. And we can make that a little more specific for this particular line, right? Because y, we know, is 1 over initial velocity. M, rise over run, right? So 1 over Vmax divided by run, rise is 1 over Vmax, run is 1 over Km. That looks messy, doesn't it? And really all it is Km over Vmax. So let's rewrite that. Just a quick note that can be simplified. So Km over Vmax times x, which is 1 over the substrate concentration, plus b. Okay, so b we know to be the intercept, right? Awesome. So this is the equation of the line described by this function, and in fact it shows you right off the bat that we can calculate, if we know the equation of the line, we can calculate both Km and V max, excuse me. So what if I said that we had an equation for the line that basically was y is equal to 0.4 x plus 0.2. Okay? There's a couple ways that you could use this equation of the line to allow you to calculate both Km and Vmax, right? One way that you could do it is just simply by using what you know from this equation. So you could just say, oh, I see that 1 over Vmax equals 0.2. So you could just do that. 1 over Vmax equals 0.2. And then basically just taking the reciprocal of that, right? So Vmax then and that is going to be equal to then 1 over 0.2 which is then, of course, a value of 5. And on your graph, if this were giving you the equation for a line, of course the units would have to be specified there, like 1 over substrate in micromolar, and 1 over initial velocity in, micromole per minute or something along those lines. So it'd be, micromole per minute. Okay, great. So then that would give us Vmax in micromole per minute. Cool. So then we could go ahead and we could figure, now that we know Vmax, we could figure Km by just simply knowing right here that Km over Vmax is going to be equal to 0.4 on the equation. So let's erase and go ahead and do that. Alright, so Km over Vmax equals 0.4, and we now know Vmax is 5, so Km equals 0.4 times 5. Okay, and then that just equals 2. Excellent. So then that should give us the value in micromole for substrate concentration. Now there are other ways that you could also go about doing that, right? You could also just say that I know that the when the x value is equal to 0, so at the y-intercept where x equals 0, set x equal to 0, that would give you 1 over V max as the value there. So if you just go back to having your equation, right? So again, y equals 0.4 x plus 0.2. So we know that when x equals 0, y is 1 over V max. So let me actually just plug in for that. So this is going to be 0 plus 0.2. So again, 1 over V max 0.2, which is exactly what we got the other way. V max is going to be equal to 1 divided by 0.2, or 5. Right? Same exact calculation, really, just different approach to it. You could do the exact same thing for finding the Km. Because you recognize that negative 1 over Km is equal to x when the y value is 0, so we would say at that 0, 0.4. So subtracting then, we'd have divided by 0.4 equals -1 over km. Okay, excellent. So basically this is -1/2 is equal to -1 over km, or km is equal to 2. Excellent. Two different ways to go about the exact same thing, but you should get the same values regardless of how you plug in there and how you use the equation. So this Lineweaver-Burke plot is another way to go about things where you're graphing 1 over initial velocity versus 1 over substrate concentration. Much simpler way to get the values of Km and Vmax, and then thus from the value of Vmax you can sometimes go ahead and calculate the value of Kcat. So as long as enzyme concentration is known, right,